Hey guys, Travis Gillespie here. We're looking at arithmetic sequences, and it turns out you can find a specific terms value in a sequence as long as you're given the right tools. So the tools that we're going to be given here is a formula, and this formula in the textbook, it's going to be written as a sub n is equal to a sub 1 plus, and then inside parentheses here, you have n minus 1 times d. Now I like to change this up a little bit. If you like this formula, go ahead and use it. I'm just going to change one thing. I like to lead with my variable, so I'm going to lead the parentheses with d here. So I'm going to just change colors and rewrite it the way that I like to use it. So I have a sub n, it's equal to a sub 1. In fact, that looks like a 9. Let's fix that. A sub 1 plus d times n minus 1. And now I can talk about some of the specifics inside of this equation. So a sub n is just a specific index. So the index that we're looking at, or the index that we're interested in, and the index we're interested in here is the 10th term. So I'm going to substitute 10 in for n here, and I'm just going to get started down over here. So I have a sub n is going to be, in fact, maybe I should do this over here just so it stands out below that equation. So I'm going to change colors again. So I have a sub, and that looks like that 9. So a sub 10, and I'll fix that 0. So a sub 10, it's equal to a sub 1. Well, that's the value for my first term. So whatever my value is in that first term, which happens to be 1 here. So I'm going to substitute 1 in for a sub 1, and I'm going to add that to whatever my value for d is. And d, really what it's saying, it's the common difference. So what's the value for the common difference? And I actually have to go and calculate that here. So let's find that common difference real quick. Well, the common difference, well, from the difference between 3 and 1, the difference between 3 and 1 is going to be 2, and the difference from 3 to 5 is also 2, and the difference between 7 and 5 is also 2. So the common difference, d, is going to be 2, and I'll substitute that in for d here, times n minus 1. So the way to think about this value here, in fact, I want to do a couple things. This is a positive 2, not a negative 2. Okay, so now that you know it's a positive 2, I'm substituting positive 2 in here. Well, what's this value for n? Well, that's my term, my 10th term here. So I'm going to substitute 10 in here. And another way you can find this is just look at that index, and you see that a sub n is 10 in this case, a sub 10. So I'm just going to substitute that value 10 in for n minus 1. So what this, and I'm going to fix that parenthesis real quick. So what this is telling me right here, I'm moving out to the 10th term. But since I'm starting at the first term, I'm only going to move forward 9 more terms. And I'm going to think of this as the new difference. I'm going to think of this as my new difference, or my value for my new difference, and I'm going to add that to the value for my first term, which should give me the value for the 10th term. Okay, I'm going to change colors. All right, so a sub 10, it's equivalent to 1 plus 2 times, well, 10 minus 1 is 9. All right, and I'm just going to keep simplifying this. A sub 10, it's equal to, well, 2 times 9 is 18, so 2 times 9 is 18. Let's fix that 8. So 1 plus 18. All right, so a sub 10, it's equal to 1 plus 18 is 19 here. So the 10th term is going to be equal to 19. Okay, so here's the next problem, and I want to find out what the value is going to be in the 18th term. So the first thing I'm going to do is just find the common difference here, and that's going to be pretty easy. I'm just going to make sure it's consistent. I want to fix that arrow. Fix that arrow. Notice the sequence is decreasing, so my difference here, my common difference, is negative 7. Negative 7, it's decreasing by 7. So now I can move over to my equation over here, my formula, and I want to know what a sub 18 is going to equal. So a sub 18, well, my value for the first term in a sub 1 is 100. So I'm going to substitute 100 in for a sub 1. And I'm going to add that to the common difference, which is negative 7, and I'm just going to plug that into parentheses for now. Negative 7, And off to the side here, I have n minus 1, and n is the 18th term here. So I'm going to just substitute 18n and subtract 1. Okay, and now from here it's just a matter of running through order of operations and just simplifying this equation. So now a sub 18, it's equal to, well, I'm going to start out with 18 minus 1, which is 17. So we have 100 plus negative 7 times 17. So negative 7 times 17 will give a value of negative 119. So a sub 18, and that looks like a 9 again. A sub 18, it's equal to 100 plus negative 19, or 119. So 100 plus negative 119. A sub 18 is equal to, well, 100 plus negative 119 will give a value of negative 19. So the 18th term is going to equal negative 19. Let's look at another problem. Okay, so the common difference here, it's going to be 0.5. I can see that all the way through this sequence. 0.5. And again, I know it's positive because my sequence is increasing in value. And now I'm going to use my equation here. I actually want to move this stuff over just a little bit, all this information. So now to write out the equation here, I have a sub 21, it's equal to, my value for a sub 1, my first value, or my first term's value, is 25. So I'm going to put 25 in, 25 plus, the common difference is 0.5, 1/2. In fact, I'm going to use that fraction 1/2 times my value for n, it's 21, 21 minus 1. Close off the parentheses here, and now let's move forward. So we have a sub 21, and I'm going to fix that 1, is equal to, a sub 21 is equal to 25 plus half of, well, 21 minus 1 will give a value of 20 here. All right, so a sub 21, it's equal to 25 plus, well, half of 20 is 10. So a sub 21 is equal to 35. So that tells me the 21st term is going to equal 25, or 35 in this case. And I'm going to rebox that up. Cool. Let's look at one more. Okay, so this one looks a little different. Don't be intimidated by it, because I actually think that the work's been simplified for you quite a bit, because you're already given the first term's value here, which is 13, and you're also given the common difference. You really don't have to do much more math other than just substituting all of this information into your equation here. So I want to just, I already have a new color, so I want to know what a sub 14 is. What's the value in the 14th term? Well, my first term's value is 13. 13 plus, the common difference is 5. I'm going to multiply that by 13 minus 1. Okay, so a sub 14, it's equal to 13 plus 5 times 12. Okay, so a sub 14, it's equal to 13 plus, well, 5 times 12 is 60. Okay, and I'm actually looking at 60 here and noticing I made an error up here. I substituted 13 in for n, but n represents the value for my term, the nth term. So n should be 14, not 13 here. So that's an easy fix. I'm not too concerned about that. I'm just going to go and wrap around that information where I made my mistake. I'm not going to rewrite everything that we worked through, and I'm just going to fix up that part of the equation there. So I'm going to go back to my pink pen first. In fact, why don't I just use orange throughout just to show where my error was. So n minus 1 here will be 14 minus 1, and 14 minus 1 will give a value of 13, and 5 times 13 will give a value of 65. Okay, so now from this point all I have to do is add 13 and 65 together, and I'll find out. I'm just going to change pen colors now. So I'll find out here that a sub 14 is equal to 13 plus 65, which is 78. So the 14th term here, the 14th term, will be equal to 78. Cool, I'll see you in another video.